All right. I am not sure, by the way, where they are in this book, because who is reading this was Renan. Quite frankly, I'm reading this one. SQL Pro, SQL Server, Pro Server internals, I think. From here, this one. So I was reading this book here, from this guy Dmitry Korochevich. I don't know how to say.
Wait, I think I know that book.
Yeah, I think I sent you.
Oh,
But
okay.
I'm reading this book here, and the point is, like, he describes, I think, on chapter one even, how it stores, and depends. Like, it's very dependent on like the vendor you are. I don't know
Sure.
how Postgres. I got this one here from that site, but I don't know how they implement. Probably it's different because here's the thing. Depending on the vendor, they like SQL Server and what's the Oracle one? Oh, I think just the Oracle
Yeah,
database.
isn't it just Oracle?
Yeah, I think it's just Oracle. They implement a file system and then they store stuff atop the file system. Okay,
Uh,
so they make their own file system, and as you can think, that has some benefits, by the
of
way,
course,
but
but
that has also like very good, very bad downsides. For
it is
example,
another hole that you can trap yourself in, basically.
it is, think of this, to port that to another operating system that might not be compatible. So you need to basically do you see some tricks there to make it work. So for example, SQL Server, it was hell for Microsoft as far as I know, for them to port it to Linux, and they never ported it to macOS. So it just works on Windows and now on Linux. It could be that Microsoft also didn't want to, but anyway, they
Hmm.
have infinite money, so probably they could. But anyway, you got the point. Um, so
Sure.
that is the background. So we can go with any implementations, but here's what I'm going to say. The implementation, I think, is the thing that least matters in the database. How you store things. Of course, it's going to have consequences. If we do something like really bad, it's really going to reflect on how we access things on the
Yeah,
future.
I think the performance will suck. But I was already expecting the performance to suck, so.
Yeah, that would be. I don't think we're gonna even be able to measure our performance checking.
What do you
Um,
mean?
yeah, I mean, okay, let's see. But we're not gonna write a file system. We could, but I don't see the goal here. Like,
That
well,
that could be a future, completely a
that could be
future
a
thing.
project, a standalone project,
Yeah, a
right?
standalone thing.
So okay, let's ignore that. So let's focus on just doing the file system. So how
Well,
I
if
will
you're gonna
explain.
make an operating system, you're gonna need the file system anyway.
Okay, of course. So okay, I'm gonna give a quick overview, very dumb, very high level of how SQL Server handles this. Okay,
Sure.
so it has its own file system. It would be nice if I could draw, but picture this. Just stay with Uncle Bob.
You can try to draw an Emacs
Uh,
if you want.
oh yeah, that's true. I have artist mode.
I was not thinking about that, but sure.
Artist, artist mode. There it is. So you have, think of this thin layer here is it would be a square, but anyway, you got the point.
That's a square.
This thing here is the disk, okay? And then
Sure.
you have the logic layer up here. What is the
Mhm.
logic layer? Well, the schema and all the stuff you have up there, right?
Mhm.
So uh, you would have a logical representation of what it means to be X and Y. So you would have, I don't know, table A, which would be one relation, table B, another relation,
Yeah.
table C, another relation, and so on. And then you have the connections in between them. You have like rows inside them, which we call attributes in the relational model.
Yeah.
So you just have like attributes inside of them, and so on. So what is the how does this get translated doesn't really matter much, but how SQL Server does is uh, you have, for example, a file group and you have a file that you basically can store in a header. So imagine this being a page.
Oh, so it's basically
Okay.
metadata to find the table, I guess.
Um, kind of, yes, because you have like the index, right, to access it, and there are two main ways to access it. There are more, okay? So in SQL Server, just to give you an idea, there are like, I think, 10 ways of indexing something. You can even index blobs, you can index stuff with regex, you can do a lot of things. Index types.
Are you going
SQL
to do
Server.
pagination, by the way?
Well, of course.
Yeah, I imagine without pagination the thing will suck very hard.
Here. So you have all of these. You see, you can index like XML, spatial data, full text like blob for
Mhm.
text. You can have cluster, non-clustered, clustered, memory optimized, non-clustered, hash. Anyway, you can do a bunch of like things. I think we should only do non-clustered and clustered, because those like I think non-clustered is what everybody knows
I have
because
no
it's
idea
basically
what those mean, so
okay.
each
Everybody
index.
knows this as well. Never mind, because this is the B3. Okay, so let me explain
Oh no.
the whole flow. Yes, let me explain the whole flow. Okay, so here's the thing. We have stuff. Let's think of first on reading. Okay,
Sure.
and then I'll explain the writing because it's a lot easier. So the reading
Really?
is yes. So
That's impressive.
reading we can finish today, I think. Writing we can't. So
Okay.
no, sorry, the opposite. Writing we can finish today. Reading we can't. And who is there?
I'm
Nathan?
very Nathan. I'm very curious
Hello,
of
Nathan.
why reading is harder. Go.
Okay, so here's the thing.
Hello, hello.
To
Hello,
read,
Nathan.
so I'm just explaining like the overview. Okay, Nathan?
Yeah, he's explaining how we're gonna write and read
Why
in
do you
the
have a
system.
lot of dots there, dude?
Okay,
Because he's
let
drawing.
let me use a draw.
Oh, sure, ASCII
Draw.
art, right?
Line,
He's drawing there.
auto draw. Okay, I'll use the browser now. Happy.
Oh, now I am.
Okay, so all right. So let me first explain the read, okay? Because I think it's harder than the write. So we are gonna have a layer that is the logical layer. So this logical layer, we're gonna have a schema, right?
Yeah.
And the schema we have relations, which would be the tables, for
Mhm.
example, and we have the connections between these tables, which are the relationships between these tables. So let's just put another one here. So you have three, let's say.
Yeah, I was thinking exactly like that.
And then what we have inside those tables are a bunch of attributes, right? So we have things here.
Yeah.
So think again that this is the logical layer, okay? So
Wait,
we
the
just have
attributes are
attributes.
the rows or are the columns, by the way?
Oh, never mind. Yes, that should. I was like listing as a paper. That's why, but it's
Yeah,
confusing. So
no,
it's
I
just
imagine
columns.
maybe Magetta is transposing the thing.
Yeah, yeah. No, no, you're right. I think it's less because I was thinking of like sheets of paper, you know. But
That
anyway,
makes sense. That
so
makes
there are the
sense.
columns. So why does it matter? Because think of this. This is the only thing that we're gonna just give it the types, right? We're just gonna store the types for
Yeah.
things. We're not storing data here.
Yeah.
So this is just a representation for us to use our meta language to connect to query stuff on the disk. Okay?
Mhm.
So this is totally independent on how we are going to implement. How we're going to implement is up to us. So we can do anything. I'll describe what SQL Server kind of does. It does it way better than this, but I'm just going to give you a thing. So we have the disk. So I'll literally draw a disk. Okay, this is a disk with a Winchester thingy. So this is the disk. Okay. So oh, that's horrible. That's not bad. That's not better. But anyway, so this is a Winchester disk. So it's reading this and it keeps spinning, and
Sure.
that's the mechanical shit.
Who needs CSSDs, dude?
Yes. Anyway, so what we're gonna do is basically convert this thing here. When we get the new data, for example, we're this is a writing, okay? When we get the new data in a clause, whatever, we just write it here. But okay, think of this. This is the file in the disk, okay? The file will look something like this. Just everything connected.
Sound effects.
It will look like just a bunch of bytes, okay?
Sure.
But we're gonna to simplify things. We're gonna make something that is like easier to handle, which is like a file group. So each file will represent at max one relationship. Sorry, yes, one relation, not relationship. Relationship.
Wait, we're gonna have one file per relation?
Yes.
So is that like one file per row or
We
something?
can have one file. No, one file per table.
Oh, okay. Sorry.
Yes. Oh, so let me translate to logic. A relationship is the connection between two things.
Yeah.
A relation is the definition of a tuple. That means the table.
Sure.
And the fact is a point data that fills a tuple. And a proposition is something that you pick a fact and you can apply to a quote, like literally a sentence. So for every employee, there is a department, blah blah blah. This is a preposition.
Yeah,
A
I remember
preposition.
that from the
You see?
presentation.
So okay, we're basically gonna store all of this here in one file per each per relation. So this is gonna be relation one, and so on.
Mm-hmm.
Okay. So we're gonna have multiple of these. That's fine. Why am I doing this? Because think of this: if you have multiple relations of different sizes in the same file, how are you gonna know? It's gonna be hellish for you to find the things because here they're just bytes. So you need to basically map the correct offset in the
Yeah,
bytes.
you need to do that.
It's gonna be horrible. I think it's really.
Man, I think I'm
really
so
not-
used to much lower level
Magenta.
stuff because this for me is okay.
Man, no, it's not dude. It's dude.
Magenta.
When we go to the indexing, it's not gonna
No,
be
the B
any.
tree will be bad. That would be
Yes, it'll
bad.
be horrible. Go on, Nathan. What are you saying?
But much of those parts we can just, how can I say? Uh, they are really independent, aren't they? Like, for example, this whole part of, oh, you encode and store and retrieve and decode, like, this could be, how can I say? We could do multiple implementations for that, right? For
Yeah,
example,
I believe
one
so.
that is just literally writing on CSV
Yeah.
and retrieving
So
from CSV.
that's why I was saying we can totally make it we can that's a concept of data independence, which is your logical layer does not depend on how the data is stored.
Yeah.
That means that whatever you do on the logical layer should not affect the storage, because if you want to change the storage, that shouldn't matter.
Yeah.
So if you want to do like two different algorithms and handle specific cases, that's fine. See?
Yeah,
So,
I agree with that. Yeah, that makes sense.
so okay. All right.
Okay, tell
That
me
is
why reading is hard.
okay. Now this writing is easy, right? You got the point. You just get a table, serialize it to binary, write it here on the last thing that you have, last space available. That's it.
Sure.
There's some caveats, but they're easy to
Oh
handle.
no,
Like,
wait. There needs to be an intermediary step, right? Because we need to discover which file we need to write this to.
oh, that we can pick like the name of the table, whatever. Or the
Eh.
latest, and if you want to multiple files
Like,
of the same relation, you can do like something like check the size of it. Like there are ways that are
There
not
are
very
ways,
why
hard.
yeah.
would you want instead, Lemos?
Because I was thinking about adding pagination. Yeah.
Yeah, but okay, pagination to write we can largely ignore.
Okay.
Pagination to read is the problem.
Yeah, that
Because
I
think of this.
imagine. Yeah. Okay.
Think
Go.
of this. There are two main ways to search. Okay, there is the indexed way to search and the non-indexed way to search. Let me explain what is the indexed way to non-indexed way to search. It is called a scan, which is
Try and error.
you have this scan
No, yeah, no.
like a
But you're gonna.
scanner.
Yeah, just go. But I think it's basically try and error. Go.
Yeah, like that, but in a sequence, right? So
Yeah.
you have this, you have like relation 1, 2, 3, and then what you do is basically start on file 1 on the top, go read it, and then okay, I didn't find it. Go to file 2. You see, it is horrible because your performance goes to like the waste.
Yeah, that type of
Double
low
jump.
level performance we care, I guess.
So yeah, that's I think, but that is necessary. Sometimes that's the only thing you should resort to. You have to resort to. So when you cannot find an index, for example, or depending on the relationship, if you haven't specified an index in a bad design, usually you don't have an index. So like a normalized.
Like
So,
like a what? Sorry.
unnormalized
Oh,
stuff.
normalized.
Like,
I heard normalized. Okay, that makes sense.
yes,
Uh,
because think of this. What's the point of normalizing? The point of normalizing is bringing things close to the key. If you're
which
bringing
is
things close
indexing
to the
basically.
key, which is indexing, so you're making access actually quicker. But anyway,
Yeah. In this sense, yes. But I wonder if then the pagination will help us to discover which groups of files to search, I guess.
yeah. So how I propose us to use the pagination, because that alone is like operating system levels of like abstraction, and it's way harder to do it properly. And I don't think we're gonna do it properly. So
If
so
you have
let
to
me explain
bet, I
what
think
I
everybody here
envision.
would bet on the same thing.
So let me explain what I envision for this. Okay, we split. We have a predefined number of uh, pages, so which is way less than the disk. Like I don't know, 100, and each one of these has like I don't know, like a SQL Server, for example, it uses 8 kilobytes by default. I think I don't know if it changes automatically. I know that SQLite you can calibrate it between 1 and 4 because of like mobile devices and ARM like very like limited stuff. Um, and how does this KB influence? Because you're basically gonna read a chunk from here, 8 kilobytes, and then you're gonna get a bunch of rows, right? And then you're gonna basically build a tree upon these pages. So why does a B tree matter in this case? Because if you remember a
Wait.
B tree, okay,
So we're gonna read the entire relation then, and then we're gonna do B tree search on it.
we're gonna basically okay. So there are multiple approaches, but the one I suggest first to implement first, it's a mix of a scan and a B tree. So we read, for example, this chunk here. Do a B tree, find it, found something. No, I didn't. Okay, read another chunk, run the B tree. Okay, I didn't find. You see? So you go moving like this.
Yeah, but you're not really scanning it. You're just like grab from this index until the end of the file or until the index of the half of the thing. You're just like grabbing the data. I wouldn't call that scan because that can be confusing. This site still exists. Holy
Yes,
balls.
did I use this on graduation? Okay, so look here. A B tree is like this. So you insert two things, and then now you're gonna insert three, which is in between
I use this as
100
well,
and
by the
2,
way, in university.
and then it's gonna break, right? So, but notice one thing. We don't have leaf nodes repeating stuff. It's ordered here, but it's all ordered like this. You see? So the point is, it
Mm-hmm.
is. We're not storing. If we go here, I think this website has the B plus
I
here.
need to
We want
remember
to
all
do
the
this.
properties, by the way, because I already forgot. I just remember that it's ultra bad to implement.
Oh, don't worry. We're gonna remember
Ultra bad.
here. So it's gonna break, and then notice that it clones the things, right? So what are these clones here on the leaves? I'm gonna insert 4 now. There, broke, and then I'm gonna insert 5, and it's gonna break this. There we go. So look, we can traverse, but we already have it ordered here. So it's just a linked list, you see?
Yeah.
So the point would to use this as a B plus tree is, okay, I found the index. So okay, my index goes here and here. Okay, so start reading from here onwards.
Oh, that is what you're calling the scanning then.
Yes, exactly.
Oh.
So it's reading from here. But well, there's also another part, right? We're gonna have to translate. Like suppose that are searching by something outside the key. Let's say that will fall in a scan because that's not part of the key, and then you're searching by an attribute that probably is on the key and another that is not. That is that's a whole other different concern. Okay, but let's just fix this scenario.
Wait, so if
Uh,
you don't search for the key, you
for
don't
example,
search
you
you
have something that is indexed, like the ID, which is a number, let's say, and you are searching by a
the
date.
name or the date. Yeah, that could be the case.
So a date. Let's suppose it is like you're searching. Okay, this ID greater than this, let's say, and you index the ID, but the date you didn't. So, okay, we can basically optimize this query by basically just getting the things with this ID first. Let's suppose that it can repeat because of like this is not, this is just a part of the key, okay? So you have like a composite key of X, Y, Z, and then you're basically reading just one component of this key. Let's suppose that this ID is Z. Here.
Wait, but how are we gonna know that? How are we gonna know that, oh, we should make the date part of a composite key?
No, we are not saying about the date. I'm saying like, ignore the date for now. Think of this. You have this composite key that is XYZ, and Z is ID, okay?
Sure.
And ID is indexed, right?
Mm-hmm.
But the point is, if you search for the ID, it's gonna be still quick to find it, right? It
Mm-hmm.
would be better if it were just if you're searching the full key.
Yeah.
But let's suppose you're not. So you're just searching the ID. Sorry. So what happens is that now you have these other attributes. So after you query this, so let's suppose you have this, you reduce this part here, you abstract this part from this query, which was the ID, and then now you have this other chunk here, which is smaller, and
Yeah,
then
yeah.
from that
And then
you
you
can
scan,
query
I
the data.
guess. Yeah, no, no,
Yeah.
yeah, that part I got. But my problem is, what if I do a query in which I'm queried by the date? How are you gonna discover which ID is related to that date?
If you're doing a query exclusively by the
By the
date,
yeah, I'm doing a
well,
select,
then it's a
whatever,
scan.
where. Oh, then it sucks. Like just
Yeah.
straight up sucks.
Yes.
Okay.
I mean, like, here's like on our implementation, it will suck. Like, there are ways to make it better, but in our implementation, it will suck. Like anything on our system that
It's not
does
the
a group
primary
by,
key or not part of the key. You're done.
yes, that makes a group by, order by, like all of those things, they will suck.
Oh, I see.
So be prepared for that.
Yeah, I
So
was imagining like maybe caching the most
no,
like
that we can do. That's easy. But the point is, like, for the first time you're gonna query this, is gonna be horrible.
yeah, it's gonna take ages.
So
Yeah, okay, that's fine.
anyway,
Uh,
so let's try to do our best. But I know, like, don't go with like too much, like a high expectation on
okay,
like
we
it
should
being fast.
first
I
define
don't
the
think we're
types
able.
of data because that comes before
Okay,
serialization, I guess.
let me open here. Let me close this. And let me close this as well. Just
So we're gonna write first because that's definitely. I was prepared to much worse in terms of reading, but again I think I'm used to much lower level.
let's see. It's gonna be readable, I guess.
I think we can go
Camelot.
with the writing first and reading next, as you proposed.
Yes, writing is a lot easier.
Um, we're
So
gonna go
SVG,
fancy, or we're gonna go CSV Ooga Booga way.
CSV Ooga Booga way.
Yeah, because
No,
we
dude,
could
bytes.
we could make our own format.
Oh, we can, but why? We can. No, we can just write binary.
Um, if you write binary, um,
Uh, cannot build Camelot. What? Huh?
is it not?
Don't you
Is
want just doing builds?
Yes, but I was doing okay.
no, but it is broken.
PPX show.
I
Did I
remember
make it
this was
another
working.
branch? Did I
No,
pull in another branch?
I don't think we did. Did you pull?
I well, I just cloned the project.
Did you commit from your Mac?
I did, dude. Here.
Fix Lexer parser. Okay, so were you
Easy.
mad?
No. Wait. Wait, let's see. So it is not finding these things. And I am inside the Nix develop. Huh.
I am
Okay.
confused.
Cat flake. Nix. OCaml, blah blah blah. PPX deriving is there. Oh, I get it. So okay, this sucks because we need to use eval open env because you need to install via open stuff, okay? So this
What?
sucks. And then yeah, because this is yeah, it is not understanding this thing here. So it's not getting these dependencies from Nix. So it just picked the
Uh,
mutable route. So anyway, And I already
Okay.
installed it, so it should work.
Okay.
So Dune build, just this. Oopsie. Source. There it is. It works. So yeah.
Uh, okay,
Okay, I need to
so
open from here now. Emacs.
we now need to define the types that you're gonna have. I remember
Yes,
discussing with
yes.
Nathan, varchar, var.
So
I forgot
let's
the I
just do
forgot the
two for
rest.
now. Let's just do two of them for now. So let's do a. Oops. Right.
And we should change the names, by the way. Var and varchar are terrible.
Yeah, I don't like them. Uh, let me just. Oh man, I'm still getting used to my keyboard. Don't.
Yeah,
Let me
that's
see. Where's
fine.
the bar? Okay, here. Sorry, I've been coding F sharp. So let's do integer.
Wait.
Uh,
This is for what again? This type?
this type are the types of the columns. So
Sh-
like
shouldn't we give them names? Or are we gonna go with integer 32?
well, what better name than integer 32 do you suggest?
Uh, okay. Integer 32 is
Like
okay.
create relation. Let me put a random syntax here. Create relation. I don't know, ABC. Uh, I think we don't need. We can do a decent parser, right?
Ooh,
So we
that's a
can
good
do,
question. Are we gonna enforce table names to have capital letter?
that could be a good one, but anyway, in relation, I'm just inventing a syntax here.
Yeah.
So I don't know, and then we put a field like I don't know a, like ID. I don't know, and then integer. This.
Are we gonna
I
have
don't
other
know.
types of integers?
Uh, it would be nice having different sizes, right? So like 4 bytes, 2 bytes, like a bit.
Yeah, but we're gonna go. I don't know how low we're gonna go.
Oh, we can go high and low. Like it doesn't matter. We
No,
can
no,
go
yeah,
like
yeah.
I don't know,
But if you go for the
integer
whole
8,
spectrum, you're gonna have, I
integer
don't know,
32.
16 bits, 32,
Yeah,
64. I think these are
yeah,
the
that's fine.
base.
Yeah, that's fine. Let's just put the default is 32 for now, or
Sure.
we can just do here. Now, allowing this would be inconsistent, right? Because the user could
It
type,
would
I
be
don't know,
weird.
the user could type, I don't know,
So
5.
cursed.
All right, so ignore that. And name, let's say. Let's put person here. Person. And name, and okay, varchar, something like this. But, or just a string. Because do you know why there's varchar and just normal char?
Isn't that size related or stuff? And being
Yeah,
variable or
because
not?
it's variable size, right?
Yeah,
So like
Varsha.
the point of doing this is basically restricting how much you want to save. So let's just put list. So this is parametric. Uh, okay, let's just go with this two for now,
I know,
and
that's
then
kind of
later we
cringe, but
can.
okay.
Well, let me put T on the front. Cause how do you foresee being qualified, Nathan, on OCaml? Like require qualified, like this.
Well, you don't have that, dude.
Oh, okay. Okay,
You can put
so
that inside a module, right?
yeah, okay. And then I have to open the module. Yeah,
Yeah.
yeah, that's fine. Okay, so first of all, we're gonna basically just store on the string nothing. Sorry, nothing. No, we gotta store the size, right?
Yeah.
We need to know the
Now we need the
size.
size.
So how do you do the? Come. I think it's like this, and then you can put the number like int. How do you put like a
Yeah,
label?
yeah. You don't have a label, man.
Oh, okay. So let's do. Should we do a record then? Um, but then oh, we don't have anonymous records, do?
I think you can just use it like this without declaring the record first, but I'm not
Like
sure. Either OCaml or F sharp drop it like this
yeah,
thing.
apparently don't.
What
Expecting
is he
lead
saying?
end. Syntax error, unclosed, blah blah. Expecting lead end, blah blah.
Can't we search for
So,
that? How would we search for that? Uh, ADT, Camel.
Okay, but even this is failing.
Yeah, I
What?
think you have a different problem, man.
Really? Mm-mm.
What is the problem then?
I'm trying
Expecting
to
a dot.
find in doc.
Where is expecting a
Try to
dot?
change the case of size.
The case of size. Oh, like size? Or is it a case of this?
In the documentation, it is like that.
Oh, okay. It has to
No, no,
be
no, 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 no.
lowercase.
But you, at least according to the docs, you don't need to have it nominal. You can go straight up with the braces down there.
Okay, so the problem was the capital. Yeah, okay. So the problem was the capital S.
The power of reading documentation.
Okay, so that's a good power to have. Okay, so we cannot do in F sharp. I would just do a member here, and then like write this dot 2 byte. So 2 byte size, something like this. So we can get the byte size of this
Oh, I
type.
remember reading this from the
Since we
source
can't,
codes that you sent, and then I said to I think Nathan, I told you that he was doing that because he wanted to hard code, not have to calculate all the time the thing. You can just ask for it all the time.
so can
I
I
don't
do
know
a
what you
module?
mean.
What Mageta is talking about now is that he would do a member in which would be 2 byte size, and then instead of calculating the byte size every time you need it, you just ask it. You know what I mean?
No, what do you mean by calculating? That's calculating, man.
No, 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 no. But this is gonna be calculated only once, as far as I know.
Yeah, you're just gonna retrieve it, right?
You...
Yeah,
It's like a
retrieve it.
table.
Yes.
It's like a hash table.
Yeah,
Oh, I
exactly.
don't see a different way to do it, Lemos.
You could calculate all the time. Like you could do size of. I don't know if that makes sense in OCaml terms, but you could do like
No,
size of
No,
this.
it
we could
doesn't,
have an
because that's
object.
arbitrary, dude.
Yeah, you're gonna have to search anyway, man.
Wait, OCaml doesn't have fixed sizes things?
No, no, dude,
What?
the number we are picking there is arbitrary. You are not measuring
Which
anything.
number
You
you're talking
wouldn't
about?
be able to do that. Well, you are saying, why don't, well, we could calculate every time using a size of, but
Yeah.
that's not a thing because the numbers we want from that, they are like our choice. He's not
Which numbers
measuring
you're
the
talking
type of
about? You're talking
anything.
about the 32 there?
No, for example, the 2 byte size. He's saying that, oh, this has those specific like uh, amount of bytes. He's not getting that dynamically from, oh, what's the size of an integer in OCaml or something.
No, okay, so you can't do that in OCaml. That's what you're saying?
No, no, you probably can, but
Yeah,
doesn't
we
make
could. We could.
sense because
Yeah.
that's not what we want. And also, OCaml is a bit weird. So some things has like 63 instead of 64 bits.
What?
Oh yes, I heard this.
Yeah,
I heard
because
this.
the integers they have a bit flag to say if it's a pointer or not.
Oh, that's kind of weird, but okay. Go on.
Yes, I heard this. Okay, so with this, then that's it. We're just gonna try to do these two
Wait, can
types.
somebody explain to me what exactly is happening in module type equals a struct? I already forgot everything about
Uh,
OCaml.
okay, in F sharp, the translation is this.
That makes more sense to me, but
Yes, but
It's
yeah, that's
because
how
it
you
is a
make it.
value, you see? So struct
oh,
and that's a value.
oh, okay. The module is a struct in this case because it's a value.
Yeah, I could pass a like an element here, for example, oopsie, like a thing here to initialize it, as for example, as
Ah,
well. So that's the functor part.
okay.
Okay,
Next up.
so that's it for now. Let's just do now our schema, right? So that's the other thing we need.
So this is gonna
Other,
be the definition of the relation then.
yes, so this is the logical layer that will stay afloat in our database. Okay,
What
so
is
think of
the
this.
sorry to
Mhm.
interrupt, Magget. What is the
No problem.
philosophy here? Should is it what is the criteria to have multiple modules in a single file in OCaml?
Well, if it makes sense, dude. I don't know. We don't have a law, you see?
A lore.
Okay, go.
All right. So what is the schema? Well, it is simple. It is just a type that is going to oopsie. So the type schema. I don't know if I'm doing this properly, Nathan. By the way. So just
Just the cases are weird, but it's perfect.
Okay, I need to do make. And how do I make a map again with this module weirdness?
You call it like a function,
So
like with
make,
the make.
and
Yes.
then I pass the types here. So like a tuple.
Yeah, but you need parentheses,
Okay. Uh, let me see.
like
So
string.
okay, string. Okay, it's true, I think, right?
No, 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 no. You need the module, right? This is a type.
Oh, okay. So module string.
No, no, like string is a module.
Okay,
Like
capital
string
string.
with capital, yes. But you see one module. What the fuck you're passing would be like a tuple of modules or something.
So does it need to be like this? How do I?
Yeah, it's
In
supposed to be like exactly like that.
in the
What is
examples,
the
in the
problem there?
examples in the docs, the parentheses is touching the make. Yeah,
I
that.
don't think it matters. Unbound type constructor makes string dot underscore a type variable is unbound type declaration.
What the fuck is that?
Okay, no, no, but this thing that you're making is just a type, right? So I think you're done. If you want to instantiate a
Oh
map
wait,
with
wait.
that, you need to
No, no,
do
no, no,
dot
wait.
empty or
Isn't
something.
okay? I see.
Oh,
So
okay. The result is a module, Mageta,
oh, I see.
not a
So I need
type.
to do
No, 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 no. Instead of type T, you want module T.
module t like this.
Oh yeah, this
Yeah,
is
with
also written in here.
uppercase T.
Okay. After enclose the struct. What?
Well, the
Extension.
case he's complaining about the T.
Oh, the case of the module. Okay.
Yeah, it needs to
So
be uppercase.
okay. So we don't need to do. Okay, this sucks because I wanted to do another thing here, like a let inside, but I cannot name this scheme again. That would be weird.
No, logical map.
Lemons names things so well, man. Logical map.
I
So,
I will not comment on that.
It's better than
so
Natan's,
let,
so I'm okay.
Yeah,
but
just in your mind, I guess.
one problem, like this is a map of what to what? Just a string
I'm
to.
assuming I don't
Yeah,
know
a
that for a
string is the
fact.
key. The
Yeah, I
value
think it's
doesn't matter.
yeah, it is parametric in the value, and then you just
Okay, I
need to
see.
say the type of the key.
All right. So let's just do a function here to get the size of this entire table. Okay. So because think of this, we're
That's how
basically
many
going
rows
Oh,
then?
for. Okay, let's
that's
first of all let's
nice.
define a table. Okay. So let's define it here. I'm ignoring this two here, but we can just go there later.
Yeah.
So module, I think I was calling it entity on the
I
my
don't
other one,
recall at all.
other code. So I'll call it entity. So what is a table? Can somebody explain?
Isn't that the materialization of a relation?
It is a collection of. It is a materialization of relation. That is true. But I'm asking the specific implementation of.
Ah, isn't that a set of rows?
It is a map, right? That you map a string, which is this. The set of rows means one element, like key value, right?
Yeah.
So basically this. So it's an unordered
It's a
collection.
set. Yeah, it's a set.
Yeah. So let's just put another map inside of here. So, oh, first of all, let's declare the type. So type t
Wait, I'm
equals
confused.
to,
Isn't it? We're gonna model the table as having a map, the key being the key of the table, like the ID.
like this, like type a table, because we can have things like, for example, let me remove break. We can have things like, I don't know, procedure here. This also goes in a
Oh,
schema.
oh man, you were talking about it on a much higher level than I was thinking. Okay, that makes sense. So you're gonna put views
So
in here as well?
yeah, views, tables, everything goes here.
Okay,
So for now, let's just put the table, okay?
sure.
So what goes in a table? I basically can see two things: the name and the attributes that go inside of
It's
the
a
table.
set of tuples then, right?
Yeah. So two things, but the name kind of doesn't matter because the name will already stay on the map, right? So the table could be anonymous, because the name, quite frankly, doesn't matter.
Wait,
So
wait, wait,
maybe
wait.
for
The name
messages,
doesn't
but we
matter.
can. Yeah, because think of this. We're referencing a table here, right, on this map.
But you have to bind that later, right? Like you have the names in one structure and the data in another structure as far as I understanding things.
Yes, but think of this: the usage of a table only comes via the logical schema, logical map.
No, no. In terms of usability, it makes sense. Like you're never gonna be able to access the table without the schema. But I'm
It's not
just
the
thinking about convenience. Like, but okay. I think
Alright,
let's go.
yeah,
Let's go with
we
your way
can,
first.
let's do without it. Because I remember implementing it, like adding the name, and it was like useless. Bother.
Okay then.
So let's just add another thing here. So I'll just put an int for now. Let's do it here. So type. Okay. Let me actually put an end because I don't want to put it before or like readability.
Wait. It's type table of int. The int is there because.
Yeah, just and just because I'm still defining, so I don't want it break in
Oh,
my
okay,
face.
okay, 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 okay.
So table info. Let's call it
Sure.
like this. Oh, by the way, the casing is wrong, right? It should
I
be.
have no idea.
Yeah, the casing is like this.
Let me check
Which
fractamo.
I'm not like. I'm not very fond of it, but
Yeah, it's a snake case, I guess. That's the name.
it's kind of blasphemous that a language called OCaml has a snake case, right? It doesn't have camel case.
That's so terrible. Terrible
Yeah,
joke, dude.
but they lost the opportunity, man. What the heck? Okay, so
Like I was
uh,
expecting this joke coming from me, but not from you.
ouch. Okay, so this should be a module, right? Okay, I'm interested in how this is gonna be done because this should be a module because it is a map, and then we get the type of the map, which is a string.
Yeah.
Ah. But the other thing inside of it,
Wait, wait, wait.
we're
There's a
gonna.
problem. You cannot
Okay.
name the module without capital letter.
Kill me. Table info.
Ooh, capital snake. I don't know about that.
Yeah, that one is a bit of a polemic. You don't have a right way to do it. Even on the standard library, some modules are in one way and the others in
Yeah,
other
I
way.
was
Like,
I was trying to do LLVM with this, and I got pissed because like the module, like in F sharp, it is LLVM, like not like this, but it is like a full bang, but it's full like capital letters, right? Or when you import things from .NET and like net, right? Here it is LLVM, and I find it
yeah, that that was just a weird choice.
Sure.
It's not that you
No, wait.
need
Let's
to
a
do that
little bit
way.
consistent. If you're gonna use snake case with the name of the modules, logical map needs a snake there.
okay. Dude, one thing, when we do this, are we passing the type of the key or the other thing?
The
The
key.
other thing, the key, which is not what I wanted to enforce, but
Oh,
okay.
Mageta, I actually have a point here.
Mhm.
Do you remember about the files being modules by default?
Yes.
In the way you write the files are in snake case, right?
Mm-hmm.
Uh, so the way they transform in module is they get the first letter and do an uppercase in it. So it would be like table info, but only the
Oh,
T is uppercase.
okay.
Because when you are dealing with modules that are files, they will be different than that.
Yes. Okay, I get it. Okay. That
Can
is justification. I'm not sure if I like this justification, but well, I can accept it. I can swallow it. Okay, so here's the thing. This is a dubious choice that we probably will want to review later. And the type, which, oof. Okay, so let's put it here. Here. Okay, so the type of here is a type, not T. All right, so let me explain. So this field metadata is each field inside our map, right? For our table. And our table is going to have an instance of this crap here with this type inside as the second parameter. So in F sharp, it would be something like map string, which is the key, right?
hmm
And then the second is the field metadata.
How do
So
we do
this.
that in OCaml? That's a very good
So
question.
it would be this.
Yeah, so tableinfo.t is a type, right? And receives the second type that you
It
want.
is a type, and then I need to pass field
Yeah, but
metadata.
it's the opposite, right?
Oh, I see. So like this,
Yeah.
right? Hey,
Wait. Can you repeat why that's the case?
like when you do int
A
a,
list.
Oh, I remember that. Yeah.
so it
Yeah,
is the
yeah.
same. It's the same thing.
But
Like
in F
That's a
sharp, you
weird
can
thing.
reverse them if you use the angle brackets.
no, that's in F sharp. Here
Yeah,
it's
F
not.
sharp. That's what I. Maybe I said something different. Sorry.
No, no, yeah, I thought you're talking about.
Okay,
Okay,
but
so
before I continue, can you please change the logical map to also be snake case? Yeah,
the
man, that's
logical
triggering
map
me. Like.
also. Oh, here.
Yeah.
Perfect. Okay, perfect. On the measure of what is possible. By the way, how do I make something private like this? If I don't want to share something, okay, a type I know it doesn't matter. It doesn't make sense. But how do I make
Of
something
course it
private?
does.
A type?
Sure, if you don't want to expose it, you don't, right?
No, but dude, if I'm exposing this high level type, it doesn't make sense to shadow like to hide the type that it has inside. I don't think that's even possible.
Well, the first thing is, are we talking about completely uh, making it private, or are we talking about making it abstract? You see?
Okay, let's see.
But yeah, I'm not sure if you can make it
Yeah, no,
completely
no, but
private and show there because,
yeah,
well,
but
it doesn't make
don't think
sense.
about a type like a method, like not method, a function like ABC, like this. Let's suppose I put a
Sure.
value here. How do I make this private?
Oh, I think you need to use this. Oh, no, wait. I think you need to use the signature, but I think they added some features to make it private without the signature.
Oh, there is
Uh,
private. There's the keyword
Let me see.
syntax
They have
info.
like two different modifiers. I don't remember.
Oh, by the way, there are classes also, right?
Private
Yeah,
values in OCaml.
We
you
can use
have some
this.
stuff.
Levels.
You do have the private, and you have some other key,
We can
but
use
I
this.
don't think they are what you want.
Don't you guys want to use this?
Is that the very famous object system or something?
Yeah, that's the evil way to do stuff.
The evil way. Yeah, I'm not
We
finding
can
an easy source for
we
making
can
it
start
private.
implementing, I don't know, a flyweight pattern here. We do classes.
Lemos, look at the chat.
Uh, okay, so did you guys get this thing here?
Let me try to rephrase this to
No.
see if I get it. So what you're doing, you're creating. Oh, Nathan was not here when you explained the thing. So Nathan, the entity is actually the group of possible things. Like I'm gonna call it possible things because I don't know how to call it, but it's the possible things that you can do in most vendors of database stuff. So you can have procedures, views, tables. So these are the entities, okay? And then
Hmm.
we are only gonna have tables for now. So
Yeah, it's just this.
the table is composed out of a map that is making a connection between a type that we
Hmm.
defined before uh, and a field metadata. The field metadata will say the position of. I guess we are now controlling the position of the columns. That would be the way to say it, I guess.
It is I will explain this further, but this should be the position on which we're gonna use to serialize things in an
No,
order.
yeah, that
Wait
also
a
participates in that.
second. Shouldn't you have multiple stuff in one table? Because right now you don't.
What do you mean?
I mean, you
Uh,
should have multiple fields, attributes, or I don't know, in one table, right?
Yes. Isn't this a
Right
map?
now. Ah.
What I want.
Oh, okay. I see what you mean. Oh,
Wait, the key
I
of the
see. So,
map, the key of that map will be the
mm,
ID, the key,
okay,
right? The key of
now I got it. But
The
then I ask
key
you, do we have a
will be
name
the
for the
name.
table?
We don't here. That was what I was talking to Lemos. The name of the table. Do you agree that it's already going here? Isn't it this?
Yeah, you're gonna have to glue them together later, Nathan.
Like for example, procedure. We don't need the name
Okay,
for
you
a
have a map
procedure.
to the tables, right?
Yeah.
It would it we okay. We might need it. Okay, because think of this. A procedure it can be recursive. For example, a function could be recursive.
Mm,
Correct. So how
yeah.
would you know what is the call that you're making inside of the thing? Well, you can go in the logical map in the schema and search for it, and you're gonna fall into yourself. So it would be more practical already knowing which one and already just searching here, because you already have the entity, which is you, right?
But this entity thing is like the well schema, right? Part. It's not where the actual data is, right? And what do
Yes,
you mean
yeah.
by what do you mean by position?
So
Okay,
it's a
so
position in the, like if you have a row that is composed of multiple columns, how do you know
Mhm.
which one comes first?
yes, because think of this, you're gonna translate all of this trash to bytes. So
You
when you
could
write,
do a list for that, but because then the
do
list will
list,
come for
Ah,
the positions.
okay, an array, right?
Yeah.
Okay, yeah, that's possible as well. But the point is, like, if you just give me a an element, I would have to know what is the order that this element is stored in the disk when I'm fetching and
mhm.
Yeah,
recomposing the
exactly.
row.
Yeah, you could read what the fuck the map gives you in terms of invariant, right? See if it
Mhm.
really is consistent about the order of stuff. But it's probably not indeed.
I have
So,
questions.
okay, go on.
So the table info, that table that we are constructing in the type T inside the entity module, that thing is actually constructing a row. And then the map is a key, which is can be the ID, like a key in the relational model sense, okay? So it's not only a key of the map in terms of how we are implementing it, but it's the key of the table, of that relation, sorry. And then the other columns, they go there, and then the map can have multiple lines, so multiple rows, so that's why we need a map instead of only a tuple, I guess.
Multiple rows.
Does that make sense?
That those are the columns, right? Like the name of the column and what
Yeah,
is the type of it.
those are the columns. I think.
Wait, where is the
Explain
column?
again, Lenny. Explain
No, I
again.
It's
want to
because you don't
understand.
have.
I want to. Can you? Okay, maybe it will be shorter and clearer to me to understand. What is the table info mapping? This
What is
map
the
is composed out of a string and what?
The
Uh,
other thing we don't know yet on this declaration.
No, no,
That's why
no.
I
It
didn't
is
like
field
it.
metadata, but this field
Yes, it is this.
metadata,
So it
what
is
these maps
basically like
represents? That's my question.
okay, okay.
like column name to column type.
Column
So
name to
table
column
has
type.
a.
Oh, okay. Okay, I'm done.
You see? So it is the table.
Yeah,
So the
it
column
is a map between the type and the name. The type and the name? No, the
Mhm.
type and the position, I guess.
The position, yes.
Yes,
Position
okay.
you're gonna write it
Okay,
in.
so you know that the column X is in position A and it has the type whatever.
Mhm.
Okay. Okay.
Okay. So all right. So we are half done, I think. Now what we need to do is on this schema here, make a type T that is basically the same map, but abstracted with that. Let's actually put this downside. You could do the recursive, but that'll be cursed. Put it here. Here. So we can basically just say, okay, it is an entity dot t, right? That is this key here,
Mhm.
and then with that logical map, map dot t. Does it make sense?
And so it is a recursive. Yeah, okay. The type T of the schema is composed out of the type of the entity and the type of the logical map, which is then is recursive, I guess. Is that it?
Mhm. Yes.
Okay.
All right. So that's it. We have it. We have everything necessary to start writing to disk. So let's just do. How should I call it? Disk.
Yeah,
I'm gonna call it disk.
sure.
So okay. What are the things we need?
Oh, dude, we should actually make a module called IO to do reading and writing, I guess.
That's a good idea, actually. Okay, so instead of disk, I rename it. Uh, rename.
And then you can do a IO module or something along those lines, and then you can read and write.
Okay. So module, write, struct.
Yeah.
Okay, good idea. Okay, so what? Why does it? Oh, I need to build, I guess. Let x equals this.
Imagine that is a completely horrendous. Oh no, it worked. It's
Yeah.
a completely horrendous process to create a file.
Oh, I'll be cursed. Okay, so let's
But
start
that's that. I
by.
felt that with Rust, by the way, and I hate it. But okay, go.
So let's start by doing something that handles the conversion of one. Okay, we're forgetting. Did we define literals as well?
Yeah, we call it values, I guess.
Values. Okay, so we have two. Perfect. So okay. E. E. Let's call it. If I change the name, it's not gonna break the parser. Let's ignore it.
Oh yeah.
The problems to persist. The problems to persist.
The problem is the bug that we know Magenta will never solve.
So let's make something here that picks, first of all, the schema, right? So we need the schema. From what was the file that I was doing?
Don't you have to open it, or are we gonna use like qualified stuff?
Just qualified.
Sure.
Fine. So schema.t. This is kind of big A, but so schema. We need to convert something inside this schema, right? Okay, we can change the approach. We can do convert the specific, like the whole row, or convert one thing.
No, I
In
think
the
we should
row.
do
And
this.
then,
I think we should do the first, first the
yeah,
unit, then the group of
yeah,
units.
I prefer that because then we can just loop over the elements.
Yeah, we're gonna fold probably.
Yeah, fold. Yes. I think that's exactly what I did. Okay,
Yeah,
so
imagine.
so we need a name, right? So name and oopsie, like entity, no attribute name. Attribute this, which is a string. We're forgetting something.
Wait, I'm confused. Isn't this function supposed to pick a type? Not a, no, a type?
Yeah, we're lacking the literal here.
The literal.
Which
Wait,
is the
why
value.
do we need the schema again?
Why do we need the schema? Because you got the type here, but imagine it's a string. You need to have the user assigned bytes for this string to know the size, the
Oh,
maximum.
okay.
So
That makes sense.
that's why. Okay, so let's do just a match.
Oh, so you're gonna do a lookup on the attribute name, pick the size, and then
let's do it. So
serialize it, I guess.
So yes, I think that's it. So we're gonna look into the attribute.
That's a good question. How do you do lookup?
Okay, I think attribute equals to map dot. How do we do a lookup on a map, Nata?
That's
You created your map, right?
It's dot find.
Yes.
So use it.
Okay, so I need
That
to do
didn't help that
AST.
much.
Okay, so it would be something like.
Isn't it schema? No, not AST.schema.
Not
I think it would be. Oh no, it is correct. That's what you. That's. I think it's kind of there. But
No.
I'm not sure if it's .t though. I think maybe it's
You
something
created
else.
a module that is a map, right? That's the one you need to use.
Oh, there you go. Yeah, makes sense because that's the one
Oh,
an
man,
attribute.
I really want to open the thing now. It's too huge now.
Okay. Are you happy?
Yeah.
Okay.
And then you define, then you put the key.
Fine. Does it give me an exception? Please tell me it doesn't.
It does.
Oh,
You have a find optional. No, it's underscore opt, I guess.
there's a find first.
What the heck is a find
Find-
first opt? Why?
Find opt. I hate the names, man.
Wait, what find first opt does?
Oh, it finds the. Good
That's a
question.
good
Like
question.
that's a good question. Like, isn't find already just find one? Like the
No, no,
What
first.
is
no.
find first?
Like, what
We
does it mean to
return.
have a map that has two
Oh,
keys?
okay. It's because you get a predicate.
Oh, I see. So
Oh,
where f
okay,
is a
okay.
monotonically increasing function. So
Yeah,
the
this could be
order.
a much better name.
Yes. Okay.
That was kind of weird, but okay.
Okay. So find opti, and then we just pass the key.
And the
Yes,
map.
and the map. So schema. Already, let's pass it here, and the attribute, and then we have this. Okay. So oopsie, forgot the. Okay.
Then you do
So
match, I guess.
now we just do match. Uh. Ooh. Oh, we could do.
Yeah, that is what I was about to ask to not. Oh, okay. You were done, just gonna F sharpie the thing, but I was about to ask Nathan. What do you? Is it common to do match with a like not a name but an expression, or it is the convention to just put everything in lets and you do the match on that?
You mean that or let first?
Yeah. So do you see that we have find opt attribute name schema, and then before we were doing a let to put that to a name, and
Yeah.
then we would do a match with that name, correct?
Mm-hmm.
Is it more common to just do the match with the entire expression, or you actually have a preference to use the lets, or is
No
just personal
idea.
preference?
No idea.
Okay.
What people do in general, no idea. I would do that if wouldn't I wasn't use the name again, right?
Um. So this, and let me just.
Magenta, you can always do the match with and put this whole expression in the between.
Oh no, dude, that's cursed.
Uh,
No, you
And
mean putting the
why is it
expression in
not here?
between that find opt?
Yeah, like here, like this. And then I don't type anymore.
oh yeah, that's
That's that's cursed. Okay, so this.
Why is
Huh,
it complaining about
how
that?
that's weird.
how do I?
Why do you?
I open AST. V.
Maybe st.value dot.
I mean, you don't need the type.
Hmm.
No, it's too
Yeah,
long.
So
that's strange.
the type of this, like in which module is it?
In the
It is
ast.ml
showing the
one.
correct type, dude. Look.
AST dot. Well, so it should be AST.
So it's Emacs nonsense.
No, dude,
Oh, dude,
this is
maybe you.
very bad.
Wait, you are even opening. So what the
Oh no,
fuck?
no, wait. This is an entity T. Never mind. We're doing something wrong here.
Oh.
Okay, so this. Okay, what I was supposed to do is an option. So some.
Oh yeah, true start
we
have
were
the
Yeah,
completely
OP,
no,
right?
lost, dude. We completely
yeah.
lost it.
Okay, so attribute. Okay, and then non. We're gonna do
No, no, wait,
favorite.
that's an entity, right? Not an attribute.
No, yeah, that's
That's
not
an
that. Yeah,
entity.
that is correct.
Thank you, Nata.
It's an
What will I
entity.
do without a Nata? Okay, so we can do already something here like entity uh, table, and then just get the table because it should be a table. Otherwise, well, what are we doing?
Well,
So
that will not be the case when we add the other things, I guess.
yeah. Later we were gonna pattern match individually.
Yeah.
For now, we can just ignore. It doesn't even exist this case actually. So okay, so with the table, we can now
Well,
we
if
can now
that
have
was F
an
Sha, he
other
would
map.
not complain, man.
You can add a flag. You can add a flag. Oh, first of all, I wouldn't even realize that it is buggy because the LSP wouldn't be working. So that's the first thing. So that's the first step to the tragedy. But you can add a flag to make like these things like it actually complains about warnings though.
No, no. For a lot of things, it doesn't.
No, the
On this
reason
it would.
No, the reason
Nasha.
is Maggot, because Nathan, when he was making the pattern matching for silverware, he was testing in F sharp, and, and he got surprised that, dude, it's a companion about this. What the fuck?
And Camel, it did.
Yeah.
Let me just apply my friend. A second.
Now we need to acquire the type of that thing, right?
Yes. So okay. So now we have that. We just put the table here. Actually, sorry. The table is the schema of the logical map. So okay. Wait, is it a logical map? What? No, that's
No,
not.
it's not going to be logical map, no.
Yes, that is wrong.
It's
It
going to be
is
table
entity.
info, I guess.
Table info. That's true. Thank you, Lemos. Okay,
Uh,
so we're searching by what now?
I think it's the same attribute name. I'm crazy?
Ooh, wait.
Well, what is even that function? Can you can you
Okay.
guys repeat that?
Okay,
Yes,
so
that
here's the thing.
function, Nathan, is the function that will pick an attribute name that you provide. It will pick a value, and
Wait,
it will
are you
search.
sure the name is attribute name? Because you are not looking for an attribute, right?
You
Yeah,
are.
so this one here, it is not attribute name because we need to find the
Entity
table.
first, right?
Yeah, so entity name.
Wait, entity name? I'm confused. What is the entity name then?
The
OCaml is
table.
killing my git.
Entity name. So we need to find first the table we're looking for.
Magenta,
Hmm?
we have something weird there. Because, for example, if you have a function as an entity, then doesn't make sense to have an attribute, right?
If you have a function, well, we just ignore, right? In that case.
And what do you pass? You pass an empty string?
Well, it's gonna. You're
Dude,
not. No, but wait, dude. You
we are
first of
modeling
all,
something wrong.
you shouldn't even. You shouldn't even reach here. But let's suppose you do. Okay.
No,
Oh,
no.
I see.
So
I see.
this
I
should be a
see.
convert for a table then,
I
if
see. I
you are
see what you mean.
supposing
So if you can read, you're saying that we can reach this point of execution, being a table, right?
not being a
Sorry,
table.
being not being a table, and then it's gonna find here, but then it's gonna fall here.
Well, would fall on the sum, something else.
Yeah, but right now we don't have it, so it would
No, what
fall like
Nathan is saying, Magita, is that we are allowing, because we know that in the future the sum will have other cases, we are
yes.
allowing the one attribute to not make sense in other scenarios,
Yeah, but
which is the
like a
attribute name.
view, but a view we might, right?
No, no,
Oh,
yeah,
but
Well, but
but then
in
it makes
sums
it
it
kind of make
doesn't.
then it kind of makes sense to be an optional string, not a string. You see?
an optional string.
Yeah, because the function will not use it, but the view will use it, the table will use it, and so on. Sometimes it will be.
No, but no, but wait. This is a conversion. I said bullshit because we just want to convert a table, right? It's the only thing that has info, or maybe the results of a function. Probably it does that way as well, but it acts on a table, so never mind.
Uh, okay, so you are saying that if you have another sum,
Yeah. So
then
if I
it's
have
just
another
gonna
sum,
fail.
it's gonna be here.
Okay, okay. Then yeah,
Okay,
It's
then
gonna
so
be
it
the
is specific to a table, right? The
yes,
convert.
yes. It
yes.
needs to be.
How do I make an exception?
Let me search.
What is the wait?
Error
Because you're
handling.
writing. So
Rise.
Okay.
value.
Valid entity.
So okay, the literal is the thing you actually want to write, right?
Wait, can you say again, Nathan?
The literal is the thing you actually want to write.
The
The
literal?
literal. Yes, it is the thing inside. I want to just convert the literal. Yes, that's right.
Yes. So we're actually
Reach.
doing this. The process is you know the table, the name of the table. You go to the schema to discover the type of the value, and then you serialize.
Let's already do the following. Let's add here. Let's already add like a procedure. I'm not gonna do it like now, but let's suppose you can find it. and then it would fall here, right?
Yeah.
Actually, we can just do entity
Entity
dot procedure.
underscore, I guess, in this case.
No, there's nothing. Okay, didn't.
Yeah, some things will be weird, folks. Because for some cases we want like only one, right? For example, I'm doing some update in one attribute of a table, and then this makes totally sense. But when I want to write more than one, then calling that multiple times would be
We're gonna
not
do a
ideal,
float,
right?
Nathan.
No, yeah,
Yeah, but
calling convert multiple
that's
times
making.
would not be ideal.
I don't think I agree with that.
Well, see the looks that. Wait.
Yeah, we're making a bunch of lookups, right? The ideal would be sending this,
At least
uh,
the. Uh,
sending already the entity here. Dude, let
at
me
least
look at
this
the
first
code.
lookup, it
Let me
wouldn't
look at
make
the code.
sense to repeat,
Let me
right?
look at the code I have there.
Oh, okay. The first lookup, I agree. We could do the the lookup only once outside.
Express DB.
Yes, that's a corporate name. What you should choose.
Oh yeah, dude, that makes a lot more sense. Like you pass the table
Ah,
instead
here.
of.
Yes, that's what I did.
Ah, yeah, yeah, that makes a lot more sense, man.
Yeah, so okay, let's do it. So instead of passing this and you look in the schema, we don't even pass the schema. We just pass the entity dot
Oh
t
yeah, then we can look up elsewhere. Yeah, that makes sense.
table, right?
No, no, but if you know it's a table, then you
Okay.
pass a table info, right? Oh, okay.
Okay, the element inside, right?
Like, do
Yeah,
you want
okay.
really
We
an
just want on the
entity?
table. No, no, never mind. We just want the table. So entity
Okay.
dot table info. Table. Oh,
Okay, but
T.
then we are assuming that. Okay, so the name of this function should not be convert. Should be convert table.
That's
Yes.
fair.
And then
Convert.
we're gonna have to do a pattern matching of the procedures and stuff elsewhere, right?
Yeah.
Sure.
Yeah. So this and why is it
Entity.tableinfo.t. You don't have the. Wait. You don't
like
have the T, right?
the
Yeah, yeah. I
T?
don't think you don't. You don't. Maybe you
Don't.
don't have a
Oh,
T.
on this thing, yes, no. Like
Stop
Wait.
why
complaining.
is it?
What the fuck?
Oh, I need to apply this, right?
Apply? Is
I need to
that
put
parametric?
another. Yes, it is here, isn't
Oh
it?
my fuck. Okay,
Wait.
can't you do
Could you
entity.t.table?
look
This
at
is
the
a
file?
module. This is a module. Yes.
What we
Oh, it's
want?
table inf. It's this.
Yeah, but can't you
Okay.
just do entity.t.table? You
No,
need
you
to
need
do
to
like
put
that?
this. Yes.
Fuck us.
You
Yeah,
can do a
because
alias, man.
yeah, you can't put table because. Oh wait. Ah. Okay. Here. You can't put table because table is just this, right? It is not a type. It is
Oh,
a
it's just a
yeah.
constructor. I see.
Yeah.
Oh my
But
fuck.
So
you
Okay, so we
could
need to.
make a.
Yeah, we should
You
make an
could.
alias.
let me see what did I do here. Because I'm doing kind table on this metadata. Oh, but I think on mine is different because I have a. Let's see. Let me look at this. Okay, I have another thing that is inside this kind blah 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 that has already this stuff. Oh, you see, I regretted doing this because that was kind of useless. But okay, that doesn't really matter. So we can just continue this. Okay, so so now here we do what we do is just one lookup. So let me comment this trash. Folks, I need to have dinner. Can somebody continue,
Oh.
or
Uh,
can we pause the string? I don't know.
can you do pause? Yeah, there's a
Uh,
no. The stop will stop forever. There's no pause.
okay, we're streaming on Twitch, so
I
never mind.
think there is a pause. I don't know.
No, recording has
No,
pause.
No,
can you
no.
pick it up
On
then?
OBS, I guess.
You just need to run Nix develop and then open Emacs from it. That's it. Oh no, never mind.
You need to do the evolve
Okay.
thing with the open stuff.
Yes, you will need to do the opening. Yes.
I sent you some text and link there. You have a hook for. You don't need to do that every time, right?
Yeah, but he's gonna need to install like open install.
Oh, for
Uh,
install. Oh, okay.
yeah, the ppx deriving. I think that's the only thing we need to install, but he's gonna need to
Oh,
install that.
but installing open it's easy, right?
No, no. On Nix, he already will have open. He will need to install the dependencies on open, like open. Let me see here. Open install LLVM. Suffering with that crap. What's the
Oh
name
man,
of the thing? PPX. Yes,
after
you
we
need to do
finish
this.
this. Okay, send me the comment on Discord, I can pick that up. But after we finish this, we're gonna be able to. We already did the insert, right? In the language, we're gonna be able to see like after the insert.
Oh yeah.
That's gonna be cool.
Weep. Convert. Rows. Not really rows that we're doing, but so the commands I will send here.
Sure.
Cobol. Uh, open not the nose, but just open init, then open install ppx deriving. Then it's gonna give you some open something like this, and then you max from that, and then things magically work. Oh, just build once, and then it works. I'll be back in like 10 minutes. It's not really
Okay, I will pick this up. So
just a
let
sec.
me remove.
I hope that's not dinner because 10 minutes is not. It's not really a good idea.
I think it's dinner that he's talking about.
How can you wait in 10 minutes, dude? That's not good.
Okay, so let me open my things. I will start sharing the screen to you. I'm still not sharing the stream. You need to remember me to reshare the thing on the stream, by the way. So we're gonna have like half of the recording will be black. So please. And I opened
Uh,
the wrong monitor. Cool. Should be here.
I don't know what you meant.
Yeah, the stream has no video at the moment.
Oh.
So I think we are. Oh no, we are not good to go. We're not good to go. The Nix develop thing that I need to do is using private information. So I'm gonna do Nix develop first, and then we can go to. Actually, to be even more safer, I will remove the confidential thing. Um, um, so config, which is very annoying. I need to ask Nix people how they do to like have like
These Nix
private
people.
private thing, like private Nix cache stuff. Um, please don't break. Um, so we need to do serialization. Hmm. We need to do converting to bytes and writing to disk. Is that bad in OCaml? Because printing was
Uh,
bad last time.
wait a second, man. Wait, we have some literal? Wait,
Uh,
that is something really off here.
wait, I don't have Camelot? What?
Hey,
Oh,
we
wait.
don't need all of that to write something. Wait,
I don't know what you
wait,
mean.
I think we don't. Let's see.
I don't know what you
Oh,
mean.
okay, we don't need that to serialize. But we do need that to, oh, because of the order, right? The
Okay,
position
now I
and
can show
stuff.
the screen to the stream.
Hmm, that's
So let me grab the
interesting.
commands. So open init.
Lemus, because we have the type of the columns, right?
Wait, before we continue saying things about the thing, I need to make this work first. So I don't have open.
Yeah, that doesn't sound great.
Okay, so I believe that maybe the flake is wrong.
Yeah.
Oh yeah, the flake is wrong.
It
Cool.
doesn't get you open, just the packages from.
Yeah, so we need to go here, flake. Um, we need to provide open here.
That's so fucking weird, dude. You're using Nix just
What is weird?
just to, you're using Nix to install a different package, man. Instead of using Nix already.
No, but that's
Yeah.
weird because of the deriving thing. That is the problem.
I think Nix is a big problem because you know you would need to cope with existing stuff. So it should be like straightforward, but apparently it's not.
Hook can be added to open its script to ensure that the shell
Yes.
remains in sync. Yes.
Yes, please.
Okay. So let me describe how this works in Nix. Nix is a very niche thing. So that it's basically like people selling you an idea, and until that idea get popular enough, it's gonna suck sometimes. And this is exactly one of the cases that this happens.
Well, that's not completely fair. I mean, it is fair to say that, oh, it is a niche and then it will suck, but it's not, even if it's a niche, it is a thing if it's early or not. I don't think it is that early. Like, a lot of people use that list. And, well, people
No, I don't.
don't
I don't.
use.
I don't think you understand the scale. A lot of people use
Mm.
a lot. Maybe a lot of people that you are surrounded by, but in terms of being popular, it's never gonna get even
No, but
close to
it's
like
still, like,
NPM or
isn't
whatever.
your company using Nix?
Yeah,
So they are quite a company, right?
yeah.
So even if it's like 10 people using, the thing is it early or is it mature? So man, if people are using improd like that, that's not an
Well, I
excuse.
can
And the
explain.
other
I can explain to you later some
early
caveats of.
adopters, that's bullshit.
I think you are
Uh,
completely unaware of how Nix works then, but okay.
well, I
Uh,
am. But the thing is about tools in general. And the other thing is, you really need to use the existing ecosystem. So if you don't focus on that, you are doing a huge mistake. You shouldn't expect like just to, oh, let's build the world from scratch just for Nix.
but
That's
that's it. That's what they
just
are
dumb.
doing. No, they are
So that's dumb.
everything new is dumb then. You just follow
No,
the
no, no,
legacy.
no,
Just follow the inertia. That's a
no, no, no.
terrible argument, not the
No, so you didn't understood, man. I'm saying you need to live with the pre-existing things and use them. It's not that you shouldn't build the things from scratch. It's just the existing things you need to interrupt with it
Yeah, but this is
in
the
the
interrupt.
easier
Yep.
manner.
Oh,
No, so it sucks. You can't install this library.
no. I'm saying that what you said at the end is the gotcha. You said you need to interrupt, and then you said in an easier manner. This is not as easy as it can be, but this is a whole lot better than it was before. I guarantee you.
Wait,
I
just a
I
second.
I promise it was a lot worse. And something is not working, dude. Version 3.6 of the Dune language is not supported. Supported versions of this extension in version of the Dune language. I have no idea what this means. Absolutely no idea. So, do you have Nix build? No. Um, so I believe he was doing CamelotDB. Yeah, but this is not working at all. Dune. I'm using 3.4. Why that's the case? Let me check on Nix packages. Nix packages. So Dune 3. No, it's 3.6. I am confused. Um, so let's exit. Um, okay. Then Nix develop again. And then Dune version. Now it is working. What the hell? Dune. Oh no, we need to do the evolve thing first. So evolve. And then Dune build. What? Oh, this evolve thing is breaking my stuff. Um,
Sorry, I'm back with food.
Okay,
So
so
what
I
you're
have
saying?
no idea how Magetta made this work then.
Uh, what do you have
Maybe
installed so far? You do have open, right?
when you do open, eval open stuff, like when you do this, you actually are
Yeah.
exchanging the version of Dune. So look, when you do
Oh,
mix
okay. Yeah, yeah.
develop and then you do
Because
Dune 3.6, and then you after
yeah,
you do eval, Dune is 3.4.
yeah. Can you do open help or open list? So doing there, right?
3.4
That's the
something.
one you got after the eval, right?
Yeah.
So it's because it's installed in open and the other is in Nix, right?
How can I say to not install open? No, how can I say to open to
Uh,
not install Dune?
oh, you can delete it.
Really? How
Like
can?
open and install. I
Help.
mean, that's a package manager, right? So
So clean. Yeah, but I maybe.
remove, reinstall. Is it the
Mm,
remove, delete, or uninstall? Like you can try it. Try this remove.
okay,
Wait,
so
remove a list of packages. Yes.
open, remove Dune.
Why don't people use uninstall, man? I mean, they are using
Naming
install, right? So
conventions, dude. Naming conventions. Oh, but if I do that, I lose the other thing, dude. You see there?
wait, yeah, yeah. Uh,
Okay, let's assume that Nix is providing all of this to me. So let's do
yeah,
this.
I
Okay, build.
nice.
No, it is totally
No,
broken.
no. Now that's the thing. Now you need to install the other things in Open that you need, like the PPX stuff,
Okay,
right?
so ppx deriving like that.
I don't know, man. They have weird things with the
It
name
is
of the libraries.
deriving. It is deriving. Okay, so if it asks me if I want to install Dune, I need to say no.
Mm,
I. Okay, so how do I say no to only this?
you don't. It's a dependency, right?
Oh boy. Okay, so we don't know how Magetta did it.
No,
Magetta did a
no,
miracle.
no, no. Do the following: install that, and then we see how to do it with Dune.
Okay.
That doesn't sound good.
Okay, it's still going. And then it failed on some of them, but we don't really care. Okay, so if I do Dune now, okay, now I do evolve Dune, okay, and then Dune build fails.
Okay, so instead of evolve, do the thing you do to quote unquote evolve the Nix so you get your Dune back.
Um, next develop. Okay, Dune version, sure. Dune build, no,
Wait,
no,
but
no,
did you
no,
got
no,
your
no.
version? You did, right? You
Yeah, I
just
got.
don't have the libraries.
Yeah. How did
Uh,
Magetta make this work?
so check the open list again. See what you are missing, right? Maybe just didn't install at all the errors that you ignore, right?
No, ppx derivers is there.
The drivers?
Yeah.
Back. What happened?
Huh.
Awesome. Nothing happened.
The
So as far as I
drivers.
can tell,
Okay.
the thing that you did with Opan inside Nix Develop is just a miracle as far as I know.
What?
Not didn't work for me at all.
What did you do? You did open. Can you show the commands?
Yeah.
Mageta.
Hmm?
Lemos is using Nix, man.
No, yeah, but I'm using X as well.
It's still, that's a problem.
Okay, did you run open init? You
Yeah.
did. Okay. Did you run open install ppx deriving?
Yeah.
Okay.
Oh yeah,
So
but there's a
run it
gotcha.
again.
When you do the evolve, so take a look on this. If you do this, pay attention that the version of Dune is 3.6.
Yeah,
If you do
but I'm
evolve,
using unstable, so it shouldn't matter, I think.
if you do evolve, the version of Dune changes,
Oh,
and
that's
then
fine.
this stops building.
But
Oh,
that's not a problem.
yeah.
You can
That's
either update the do not open or just use the Nick stuff again. The
could be
problem is
on.
the other
There's
one that you
update,
showed.
but there's update for Pan.
Do you want me to continue and we try this later?
I think that would be more helpful, yeah.
Yeah, let's go.
Okay, so let me just go back to Discord.
Man, why does the environment suck this much? I want to know
And you
this.
know what? Nathan wants to blame Nix.
It is Nick
No,
Flame.
no, no, I don't know, man.
So see the following, dude.
Mhm.
You are doing Nicks and you want like some incredible things. And some of them you are delivering, even if it's with something that you implemented later, like the flake thing you guys say it's an improvement, right? But
Yeah.
the other thing is, it sucks for you to use the stuff that already exists. That's
Not all
obviously
the
a
stuff
neighbor.
that exists. Not all
Like
the stuff.
like garbage, like
Hmm.
Node, then yes.
So isn't the problem in common regarding you are writing somewhere?
Well,
Not really. Like because
You are
here's the
saying
thing.
that
In
for every
Open,
ecosystem you have different problems
no,
to
no.
cope with
The
Nix?
problem is some applications they try to write. It's the Unix problem. Some
yeah.
applications they write in etc bin. Some writing etc
User slash
user
bin.
bin. Some writing etc local like user local bin. Like it is a mess.
Mm-hmm.
And some don't even write in etc at all. They write in like a little
User.
bin
No, user itself.
user user. Sorry.
Yeah.
Yeah. So anyway, you got the point. It is a mess.
Uh-huh.
So what Nix tries to solve is install everything in the same place. Oh, sorry. Just Nix. Oh, I don't remember if it's Nix or Nix store. And then store, and then you have all the packages here. And
Yeah.
then you can have duplicate packages, but this doesn't matter because the prefix of the SHA
It's a
will
hash.
not. Yeah, the
Good, but
hash.
still, you only have two scenarios. One of them is, okay, let's suppose the only problem is the writing part of the existing ecosystems, like the different ones. So, of two things,
So okay,
either you are not making so the tool is easy to cope with those things, or it is, and you just haven't done for open yet. But
Uh,
I don't think that's
it
the
is a
so
case.
here's
mixed
the thing.
bag. It is
You
a mixed bag
can,
of the two.
for example, Node. I know that it is hell to package stuff because it installs when you install stuff globally. Like because it's gonna complain because you will need sudo and it touches on places where it shouldn't, which is on like where it would be the bin
Yeah, it's
folder.
very hard to cope with things that are completely the opposite philosophy, basically.
No, but here's the thing. Open, I don't think it is because it doesn't install on bin. It installs on your home. So
Yeah.
the packages they are like isolated, you see. So I that's why I could install just fine Open.
Hmm,
.NET, the same idea. Like it installs in my home, so I can install like global, but it stays global for my
Lemos.
user.
But it's still, Lemos. If you really want either just adoption, like for a wide, how do you call it? Wide, well, for a lot of people, or you just want that people that actually use have a good time using it, dude, you had to focus on that.
Yeah, I
Like,
agree. I
I don't
agree.
know.
If
If it's
the
not first priority, it should be one of the
if
first because
if it's not compatible with the tools that you already use, that's gonna suck the experience. I totally understand that. I never sold something different. Anyway, let's continue this thing here. So what are we doing now?
So okay, what is the next thing we need to do? We have the thing,
Oh
and
wait,
we have the type and we have the thing, but we need to know. Okay, let's first do this.
we don't need the attribute name anymore, right?
We don't need what? Sorry,
The attribute name.
the attribute name. Yeah, so we're gonna need because we still look in the schema.
Oh, wait.
Because for example, look at what I did here. So an integer that's easy. You just have
Oh,
this
the
stuff.
table doesn't have the name information. That's why.
So
Okay.
yeah. So what I'm doing there is exactly what I'm gonna do here. Just gonna do a comma and then I'm gonna entity dot table No, sorry, schema. Ah, man, this fine. And then attribute name. Inside, yeah, but here's the thing. Okay, but let's rethink our stuff. Let me explain the problem. So we need to pick. Uh, we know this. We know how to serialize this array because the size is easy, right? The size is just 4. It's a v integer. We might. Okay, right now we just have one kind of integer, right? So it's gonna be 4 bytes,
Yeah.
always.
Yeah.
So we could give what exactly I'm doing here. Position. I think this position is for me to sort.
Yeah,
Uh,
probably.
and then this thing here is just the, well, I just call a byte function, and then I just ascend a tuple. So the byte array and the position.
Yeah.
And then I do this for all. But look at a string, a varchar. I have a value, okay? And then what I do with this is basically, oh, and the second thing is this sum that I search in the table, and I find the position and the type of this thing. Okay?
Mhm.
So with this, I can basically say, okay, first string, right? If the length of this value that you're trying to insert, try to convert, is greater than the storage size, the size that you permitted here, then I throw a warning that you're gonna truncate. So I'm just using this
Wait,
logger.
where are you receiving the storage size?
It is coming from the table. So do you remember? Oopsie, let me go
Wait.
st.
Da.
Here.
Oh, if your
You see
piece
this
of
type?
data is longer than we established before in doing the schema.
Yes.
Sure.
So I just throw a warning for like the user to say, okay, you can continue, but it's a warning, my friend. Like this is
Yeah,
gonna
gonna lose
cause
data.
you.
Wait,
Take care.
Magenta, don't you have some kind of type check phase to see if what you parsed it's okay with the schema, and
Yeah.
you could also do the size
Yeah.
there?
hmm So you can put the size there, but I decided not to. Well, I first of all, I don't even have the type checking part here right
That would
yet.
be compile time error for inserting.
Yes. So, but that's why I'm just handling this here for now. But well, yes, you should have something to validate your SQL,
Yeah,
your
yeah, yeah, yeah,
yeah,
yeah.
not your SQL, like your code in general,
Mhm.
your language.
Yeah, the statements. Yeah.
Okay, let's continue here. And then I get the value on the positions from 0 until the size. So just to cope with this problem. And then I say map, because a string it is a sequence. So I need to individually convert each char and then just pick the first. Don't ask me why when you
That's kind of
convert a char.
cringe, but okay.
Yes, but anyway, just compose it with like, okay, get the first position. But anyway, that's to cope with this function here from .NET. But anyway, and then all I do is just append the bytes with blanks because and this blanks is a function that gives me an array of these dimensions here. I pass a range, so start at position 1 and go up to this. Uh,
Array with what?
with 1, like your array is starting from
No, no, but composed of what? Of
okay, so
which
do you
type?
agree that you can have a blank? Like I defined a string field of like 10, but I typed only 3 characters. I mean, this is horrible.
Okay, so for array, you mean a sparse array, right?
For array, a sparse array.
Yeah, like for example, you have something on 1 and on 10, or just on 10, or I
Let
don't
me
know, it's
show.
empty,
Let me
but it
show this.
needs to have a type, right? So it is array of null.
Array of bytes.
Oh, okay, so byte is the type there.
Yeah. So it is just lower bound, upper bound, filling with bytes. That's it. Just a sequence.
Mm-hmm.
And then what I do here is just I append the bytes with these blanks. So if I typed, for example, if there are 10 spaces, or let's put 5, and I typed just A, then it's gonna be A 0 0 0 0, right? And of course the byte for A here. I just like to show the bytes.
Oh,
Mm.
this is okay. I think I see. So this is
Don't you have the
because
builder thing?
Uh, we could have another step that would pick everything in our code and already convert this stuff there, and then it would already do all this there. Or just expand this, which I think is what you're saying about builder. So, for
No,
example,
no,
a strings of
literally
type.
a class called builder for concatenating bytes or strings and shit.
That would be a good use case for the object system, I guess.
What?
Uh,
No, I'm talking like specifically the F sharp one.
Oh.
if I don't recall, I don't know. I honestly don't know.
Let's see
But
what we have in OCaml.
Yeah, but that's just implementation details. I think I got the point. The point is that if you didn't fulfill the entire storage, you're basically putting trash in it.
yes. So because here's the thing: if you want to add more stuff, like I don't know ABC, then you still have space, and you are allowed to, right? Then we just update this record, and it should be ABC.
Yeah, this is
If
gonna
you
be
start
updating a lot.
playing with it, let's suppose you start playing, and you just store these first, and
No,
then
dude, that would be
okay.
Malloc City all the way. No, 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 no.
But think
Dude,
about this: you just added this, and then you start writing other data here, blah blah blah. What is the problem now? If you want to update this value with the permissible size.
You need to malloc that and rearrange all the things that comes after.
So no, thank you. You got the problem.
mm,
So,
you have some great things, dude. You have a module called bytes for,
mhm.
well, you
I
can
think it's
guess,
going
right?
to open a channel and write, see, bytes. I
Well,
don't
I
like
don't.
opening this because I don't know the module.
Well,
Right?
I don't think you should open, right?
Yeah. So
So
contains
yeah,
copy, create. Okay, so I can create a size. 1, 2, 3. And what does it give me? What is
Bytes.
this bytes? Is
Yeah,
this
we need
a?
to check that out. So let me check. So bytes, OCaml.
I think it
Module
is a byte.
bytes.
No, what is the type? Can you see?
I don't
Uh,
think it matters.
do you
What do you mean,
think
dude?
so? Okay, so this is great. There is a section called unsafe conversions in between parentheses for advanced users.
Oh, it is an array, I think.
uh, bytes is wait. I'm a little bit confused. I'm not finding the definition of a byte.
I mean, where are the operations that you want? Because it could be abstract. You don't need the
Yeah.
definition.
Okay, so what I want to do, let's do first the integer, and then the other one will flow. So okay, what do we do for the integer? Tell me.
We need to first create a 4-byte array.
A 4-byte array. Do we?
Yeah,
If
because
we can already convert a thing, we don't, right? So
oh yeah, no, no, no. But our integer. This is because our integers already has 32. I was thinking about like 16 first and stuff.
so it has a functions to get something from bytes, but I want the opposite. So I
Yeah, you want
want
to try convert as
to
well, maybe.
sec convert.
Compare. Okay, let me. There's a bunch of
Let's first
functions.
search by the signature. So I want an int to
There
give
are
me
too
byte.
many functions, man.
We
Oh, wait.
could transform the number to a string and then convert the string to
UTF
bytes.
codecs. Oh, okay. You have binary encoding and decoding of integers.
Okay, where?
Search for that.
Are you with the thing open there?
Yeah.
I have the
So
bytes in.
there, on the left.
Oh, here.
No, no.
Uh,
Yeah.
oh, wait. Okay. So get what? I don't get it.
Wait, let me.
Okay, this is encoding. I want to. Okay, this is decoding. I want encoding. Set. Okay, set. Dude, who uses set?
That's a terrible
What?
name.
It could be
That's
like
really weird.
name. What? Man, this is okay.
Uh,
I think this is like little endian,
that's
big endian.
exactly why Nathan is so literal naming because his ecosystem
Oh,
sucks.
okay. And there's also this that we should worry
Actually,
about, which is
they
little
never
endian,
have
big
this set
endian.
yet for conversion.
What is a
Oh
native endian? Like
shit!
you
No,
do
no,
the
no, no,
video.
no. Guys, take a look.
Hmm.
They are naming right. It returns a unit. See?
Mm-hmm.
Wait, I'm confused.
So
What does that mean?
Sense.
where are they setting that shit?
Maybe
Looks
you need
like
to create an empty one and then you pass and they mutate.
yeah, you send the bytes first.
Yeah, so you need to
But
create the empty
Oh.
shell
why?
first.
Oh,
Why?
okay, 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 okay.
Uh,
Man,
That's a
why?
really weird
Probably
way
because
of
it's
doing it.
faster, dude. Like
Sure.
they like when
That's
they
a
are
terrible
dealing with
API, man.
buffers. Hmm?
That's a
They're
terrible API.
empty. It's not empty. I got
Oh,
what you want.
maybe, but I
Yeah,
don't
the
think they're.
create in returns a byte sequence of length, blah blah blah.
Oh no,
The
that works
sequence
first. That works first. So it's gonna
so
be create
for
for. You need to
yeah,
do a
but
let, bind that
yeah,
to a
in this
let, I
case,
guess.
let's not do magical shit and let's do the following. We already should have it anyway, so we should have the schema as well,
No.
right?
The schema. Wait, I'm confused. Didn't we remove the schema because we were doing the table first?
But we still need to search. Okay, never mind. We already have the type on the dropped.
Yeah.
We already have the type here, so we should match it here as well. Uh, Actually, how can I access that? How let me see. That is a map, right? So we need to search by the thing. So
Yeah.
let me type all of that. Amazing. Isn't this amazing?
I think we should do what Nathan said. Make
Yes.
an alias.
Find opt. I'm just gonna open this and then we do that later. So actually, uh, and then table. Okay, and then with this we do uh, attribute. Okay, we can deconstruct this already. So let's do. What are the two things we have there? I don't recall.
No. You can't do the constructing here
OPT.
because OPT is an option too.
But you probably don't need OPT if you are going to
Oh,
check before.
yeah. Okay. So what do I have
I can
inside?
see the exception coming already.
Yeah. Eventually, it will come.
Only if
We
you are
need
not
to
checking.
Man, the Postgres is written in C, dude. I I was
Sure.
looking at the code base and I was like, man, I would be paranoid with this thing.
Yeah, but the question is, did you ever got like a Postgres bug?
Postgres, what?
Bug.
Yeah, I did, which is the one that Hannah fixed, but
Oh, like the
because
only
it
one
took,
in your life,
yeah, but
right?
only one, and it was a very specific one of things that I know that people don't use, like XML. So it was
Oh,
like
Not
really
tested
Kenan was the
enough.
specific.
hero, man.
So unbound record position definition. Do I need to type this? Oopsie.
I
Uh,
have no idea. Nathan?
entity.
Not if you have the type on scope.
Oh, I do.
Oh, that's because you didn't
But
open.
I don't. Yeah, should open like entity or just a.
You
Let's
can
make it better.
open just in this lat.
Yeah.
Like before this lat, you let open.
Oh, I see. Ah, no, that would be more cursed. I wish F sharp had this, by the way, but that would be more cursed here. So let's ignore the position for now because well, that's not really necessary. And then I'm gonna do type. Okay, type is
I think you match, right? Now we need to match that.
yes. So match type T.
And then we need to see if it's an
Yeah.
integer 32 or a string. I don't recall what we
Actually,
pushed there.
it should already be kind of bad, right? Because oh no, never mind. This should already be yeah. Okay, we need to match anyway. Yeah, but this is kind of bad.
Okay,
We
wait,
need
but
to
then don't we need? Wouldn't it be better if we do this match of the type before matching the literal and do the literal inside? You see what I'm saying?
Yes, it would. That makes sense.
Yeah, I
So
think that
that's
makes
what
more
I did,
sense.
isn't it? Oh, I'm doing both.
Oh,
Fine.
okay. Okay, that makes sense.
Okay, could do that.
Doing both or doing,
Yeah,
first
because
the.
any other state. Oh, okay, not this, right? That'll be cursed.
You mean literal with type?
Yeah, because any other thing other than this is wrong,
It's wrong,
right?
yeah.
So,
That's
for
the thing,
example,
Mageta. If you are really willing to check first, then you don't need that. Only literal is enough, I
Oh, I
guess.
see what you mean. So what Nathan is saying is
Not for writing,
is
but for serializing.
if you do them together, you need to do the find OPT. Is that right, Nathan?
No, no, I'm
no,
saying that for serializing, you don't need the whole type thing, only the position, not what is the type, because literal
No,
has
no, no,
the
no.
type.
You need the. Oh, I see. I think I see what he
But
means.
that is if you are checking first, right? Like some kind of type checking before, after parsing.
okay. And what I was saying is like this.
Yeah, but
So
you see that this is
integer.
kind of
Oh,
redundant. Not Magita.
well, yes, we have the literal and the thing.
No, no,
Again.
no, no, no. I'm saying that if pattern match the literal and the literal is already a v integer, you
Hmm.
know it's gonna be 32. You know what I mean?
Well, I hope it is a 32.
Oh, okay. No, it makes sense. We are actually checking with the schema. No, no, no. Forget what I said. I said BS.
Because here's what I'm doing here. If I get something different, then that is on this wild card because that's wrong.
Yeah, yeah, yeah. I understand. Yeah, I forgot what I said. You're right.
Well,
But Nata, could you repeat what you said about checking before? Because this is the checking.
Ah. So, okay, you don't need to. How can I say that? Uh, yeah, you don't need to pattern match it with the type string. That's what I mean. Oh wait, you get the size there, right?
Yeah.
Oh, okay. Yeah, yeah,
uh,
makes sense. You need in that case for
Yeah, so
sure.
in this case, you are actually doing the discovery of the literal and doing the quote unquote type checking at all the same time.
It is just because that one it carries the information. The ones that don't, you don't need to match that.
No, you do. That's actually the opposite. You do.
Uh,
Because take
mm,
a look. Let's suppose that you have a v integer there, okay, as the literal. But in the schema, it
okay.
was saying
Yeah,
that it
because
should be
you
a.
don't.
You
Yeah,
see?
because you don't parse the integer 32 with some special syntax, right?
Yes, yes. Well,
Yeah,
we
makes
could,
sense.
but that would be kind of annoying.
Size.
okay. In this case, we should be an exception or something, but that's it.
No, no, no. But this is correct. I think we are on the correct path now.
This. All right. Now for let's try to make the bytes thingy. So bytes dot create, I think,
Create, yeah, and then you need
with
to use
the size.
size, yeah.
Oh, dude, this is actually useful. Yeah, this is actually pretty useful.
In the case, in this particular case of the string, I think yes, but in the other case of the number, just
Yes,
why?
that's yes, that was cursed. Okay, but how do I encode a string?
The to string, that I know.
Uh, what?
Uh,
Yeah,
It's
there's a thing called to
seriously?
string.
wait a
No,
second,
no,
man.
wait.
No,
That
from
is
Maybe
string,
that's
convert
not
from
what you
string,
from
expect.
from
string.
string.
There's no from string.
Okay, so it's not probably not off from off maybe. Off,
Oh,
yeah.
there's get.
Off string.
Yeah,
Really?
Yeah.
as
Oh.
always.
Okay, but this one it doesn't get the bytes.
Yeah, you just pass the string.
Ah,
It's
dude,
kind of
why?
inconsistent, but okay.
Okay, so okay,
Oh,
so
dude,
this
but
one.
that's easy to see, man.
What
But
do you
dude,
mean?
like, okay,
Because you have the size there. Like
no,
the
okay, but
string,
then
you know which, like buffer. If you want to do from string to buffer, wait, the
no,
other
There's a
this
case?
problem,
this
Agate.
gives a
You need to calculate the length of the string and compare to the size in this
yes.
case.
So let's do it here. Oh man. Okay, should we do like exactly like here?
Um,
We can like wave hands
Let me
and
see this
like and
API.
ignore this check of like if it's greater and like possibly truncating the things and just write anyway with blanks.
I think we should do what Nathan said, which is that just screw you, you're gonna fail, and it's your problem.
Yeah, okay.
Again, type checking.
Yeah.
Yeah, so let's serialized string equals this in. Now, okay, let's think about how to make these blanks, because this is a kind of an array, right? So this is bytes thing here. So I think we can iterate over it and append. So
Wait, I'm confused. What do you need to do now?
we need to do an if, okay,
What? Okay.
and we need to get the elen dot size. Can we get the serialized dot size or length?
Let me check.
Yeah.
Oh, there's length. Yes, there's length. Length.
Oh, but it's so. But I need to pass like this, right? Bytes.
Bytes. Yes.
Holy shit! You have create, make, init.
So,
What's the difference?
okay. So
The interface.
serialized, and it's on the standard, like on the standard library, man.
Okay, the
If
init.
this is
Lower
smaller than,
than the size.
then we are good. Smaller or equal, I guess.
Actually, wait, what? Pattern matching
Yeah,
and
you have.
exhaustive. What?
Oh, you have extend. Wait,
Extend.
is
Yeah.
that what we want?
Yes,
Let's
we
see.
want to extend. Yes.
No. We don't
But
want to
the
extend. We
name
want to fail.
it's lying to you.
No. We want to basically like if it falls on this case
You
here.
want to
that
do
means that-
padding, right?
Yeah, you want it's the case that you want to add more.
Oh, okay. This is the case that you didn't fulfill the entire size. Okay, sorry.
Yes.
It's
if
fill
you,
though.
if you,
It's fill.
Yeah, if you did fulfill already, we just truncate.
No. Wait. If you are creating from oh yeah, that's weird. Yeah, if you are creating bytes from a string, he will have that size, but you want bigger. You don't have what to fill. You want to extend
So one thing we need to do
to
first,
then
by the
fill.
way, is cut the string, right? Because if the string is greater, then we're gonna
No,
dumbly
if
serialize something bigger.
No. But if the string is greater than the size, we just fail.
Okay, I'm type checking.
Yeah.
But why is it failing here, dude?
I have no idea, but it's fill. It's the fill function that we need in this case.
Do we have few? Oh, there is.
No.
Okay.
The if is still byte dot length.
Wait.
Or we
So,
can do
okay.
regardless. Pick your choice.
Oh, like. Okay, because it can be the same
Oh.
size.
Yes.
The exactly
Yes.
same size.
Yes.
So, but why is
Lemos,
this failing? Form is not allowed. What? This is an
Could-
integer. What you're talking about?
Wait, what the length
Um,
returns? Is that an integer? Yes.
I
Yes.
hope it is.
Yes. It is.
And then it returns a float. I would be. Yes.
What you was about to say, Nathan?
this, wait a second. This form is not allowed as the type of.
What?
Do you need to have an else branch?
Oh, okay. Wait, I think that's it, but So
That's
you see
the
this
bad error message.
table info. Find out.
Okay, let me try to check. If, else, OCaml.
That's a map.
If statements.
Dude,
Put
what?
the else. Put the else. Just let us see if this error
No,
message
wait
is
a
nonsense.
second. No, wait a second.
Yeah,
think
that's not the problem there. Else.
Why is the size failing? It's not even getting that this is the size. Could it be the LSP that went crazy? Okay, let me do this.
Dude, this equal doesn't make any sense, does it? Oh
It
no.
is failing.
Wait.
This form is not allowed as the type of the inline record could escape.
So yeah, that's about your
that's-
pattern matching.
But that's worse than silverware. Like, that's bad.
I
Let's-
don't get it. What does it mean to escape?
For example, suppose you have A of anonymous record. You can't say A equals to anonymous record. You see?
A?
It is a yeah. So you have A
Uh-huh.
of anonymous record,
Okay.
right? So the record can only exist if you give it to this constructor. It cannot exist by itself.
Oh, I see. Oh man. Okay, dude, this is
That's a nominal type system. If it is a
okay.
structure like TypeScript, you could.
Uh huh.
So it's just a
Okay, that
choice.
is okay. That was strange, but I
I
get
didn't
it.
get it.
So,
Could you explain to me, Maggot?
okay. So, what is the type of this here?
Uh, I don't recall, but that it has a name.
Because if you imagine you do this, like what Nathan was saying, a of blah blah blah, and then you do a type here, like a int.
Sure.
So what happens? Where's the in which boundaries does this thing exist?
Oh, how do you
You
do that
see?
then? Do you need to make that nominal then?
So yeah, I think if we annotate, then we should, right?
I don't think it's an annotation problem. I don't think I'm understanding your code there on the match. You
Oh,
have some.
He's
what I'm
matching a
doing here is
tuple. Okay.
sum, because
Aren't you
this is the
lacking some
result
constructor name after the sum?
after the sum. No,
Yeah. Can
this
we go
is
back to the other file
this
to
is.
Like,
see
Oh, look,
how?
is that
it is even
is
in
that
furrow.
record anonymous?
No, it is a field metadata.
Okay, okay.
Try to do add the
So
type annotation first, Maggot.
uh,
Just to see.
type equals to your
The
Field
domain
problem.
failure.
Yeah, no, the problem
No.
pattern
continues.
match. No.
What are we missing?
Why does F sharp doesn't have this problem?
Uh, uh,
So
Oh,
Try to do the following. Try
I
to
kind
just
of
match
trust them.
type with a name. Just
Type
give it a
with
name
them.
to type.
Oh, just
Type
these then.
equals something. Just a name.
Okay.
Right? Now try to pattern match that after.
Okay, but that will kill the point, right? Uh,
Possible
can't you
decline.
just use the names? Not the.
I
Yeah, the
don't
names
know what
like
you mean.
if the names that you are matching, the labels that you are providing are the same names as the things inside. I remember something like that.
Like he's doing that with position.
But not with type.
Yeah. It's because we just want to test this, right?
Oh, okay.
Ah,
okay, but
dude,
why
what is
not?
the R again on this size?
Warning: this pattern matching is not exhaustive. Whatever. This form is not allowed as the type of an inline record could escape.
What?
Which is talking about this, I think, because of this, I assume.
But he's not. Dude, can we try to like just adjust some things and try to compile it? Because I'm not trusting those
No,
Oh,
but we
okay.
already tried this, right?
Oh, but why
things
is
there.
this failing?
Why with size also there?
I don't get why this is failing. It did nothing there. And yes, it is failing.
Okay.
What
Oh,
is the
but
type
go
of
there.
this?
It's a. Oh wait, now it's the same, right? The
What?
pattern.
The
Type
fuck?
T?
Oh boy.
Mm,
Oh, wait, can you go back in the?
Oh, wait.
Oh, we need the equals there in the first pattern match because it is pattern matching anything, right?
No, it is getting the value
No,
out of
no, it
this.
is pattern matching any type because the other one it is specifically asking for a t integer 32. Isn't that the case?
The integer 32.
Yeah, the second pattern
Hmm.
matching that you're doing there, you are
Yeah.
specifically asking for that. And
Yes.
but that will be non-exhaustive, right? This will never match.
Oh, yeah. You mean redundant, right?
Yeah, the error message is saying completely something different, and I don't care. But could we just add back
Values
the
of.
equal in the first pattern matching to the t string?
Yes, but then it is doing the same thing that it was failing. Which
Yeah,
is
yeah, yeah.
this.
No, yeah, but one problem at a time.
Nice.
Um,
Now he's not complaining about size. Wait,
It is.
now he is.
yeah, no, size is still a problem.
So, okay, it would be cringe, but I think what we do to solve this then?
I have no
Oh man.
idea.
No, no,
Uh,
just
right?
Control Z. Now that you don't have the problem of the other branch, try to fix the size without worry about anything else.
Okay,
Like now you
this.
only have one problem, right?
Yeah, but fix how?
Yeah, I have no
Yeah,
idea.
like what is this supposed to be? Like, is that really
See?
a size and it's an integer and shit?
Why is it? Yeah, it is an
It
int.
is, yeah, LSP is even saying it is.
Mm. Well, everything's returning a unit. That makes
The
sense.
type of this is field metadata. That is also right. And if I
If is
compile,
okay. And the
let's compile.
length is supposed to
Can
be
we
a
please Google this error message? So let me keep the terminal there. I'm gonna type.
hmm,
This form is not allowed as the type of
type.
the
The
yeah.
inline record.
Okay, so there's a Stack Overflow post about it.
Okay, some
Hmm.
people suffered with it. Uh, okay, it's doing the same thing as we are.
It stems from the fact that inline records are completely first-class objects in OCaml. They cannot be used outside of their context of their constructor. What does that mean?
Maybe we have to open something.
I am
Hmm,
confused.
Try to open type. Type is a module, right?
Oh, he's doing something different.
what is it doing?
Oh, that's
He is,
weird.
I don't know how to describe it, but he's doing a type of notation inside another thing. I don't know how to describe this. I'm sorry.
Is it this post here?
Yeah. It is that post there. So
Is
the
on
Okay.
after the edit,
FTP.
since your edited version has exactly the same problem, here's the corrected version. So the problematic version is the one above, as far as I know.
This.
Yeah.
What is the annotation? Oh, dotting line record?
The
Oh no.
the
The
type
problematic version is not the one above. It's the one above. It's actually in the yeah
this.
that.
Above, above.
So he's trying to match a specific thing inside of here. Is that it?
E Yeah, no, let's assume that the solution is after the edit in caps. That's the correct version of the code in the beginning of the post, or like the question. So what is he's doing? He's doing nothing in regards to the empty. The empty is exactly the same, the empty case.
Yeah,
But the
the only
QR
difference is
case,
the
he's
only difference is the pattern matching for separating a list and joining a list.
I don't see what this has to do with our problem.
yeah.
Yeah,
I also don't think so.
Wait, I remember this name, Octacron. I saw this name before.
huh.
Let me see.
Oh, probably the
This
community is like the amazingly big, right?
oh
It's
there's
some huge
there's
chat,
another
I'm sure.
website. Yeah, this is
It's
the
the
exact
same
same
problem.
problem.
It's just an archive. Okay, so
We don't. What is this though? I don't
do
know.
you do you pet okay, do you pick the element on the right or the left?
Oh,
It's
That's
not the
that's
left, I assume.
cringe.
uh, what left or
No.
right?
No, it's like this. So okay, let me continue doing what I was doing.
Okay, sure.
Match type T with then the cringeness, which is type. Yeah. So type dot we're on a string size this and then size in there, and then if it's something else then you fail. Okay, but why do you still happen? I
Dude,
now
that's
fully don't understand, dude. I cannot pattern match something.
Oh no. That arrow, the first one there.
Yeah, they're changed.
oh.
No, that we need to comment this out. Yeah. Oh, that do that.
What
Yeah.
the fuck?
So.
What?
uh,
Man,
okay.
I
So. Okay. So we can finish for today. It's already more than 2 hours. But this was like very, very weird. Like
cringe.
complete cringe city.
Yes, this is very cringe.
Like this is even cringer than you guys complaining that I couldn't print in Haskell.
Yes, I have to agree.
So weird. So I'm gonna finish the recording now. Stop.